In this video, we are going to review how gravitational forces relate to circular motion and centripetal forces. Now, if you remember in class, we mostly focused at things orbiting planets or satellites orbiting other planets and things orbiting stars and stuff like that. So let's first take a look at our formula for a quick review. When we're talking about orbiting and gravitational strengths, we know in this case my centripetal force is equal to my force of gravity. Okay? Now looking at these formulas, we know centripetal force is the same thing as mv squared all over the radius, and my force of gravity, which we learned earlier in the unit, was equal to the gravitational constant times the mass of one planet, normally the big planet, and then the mass of my smaller planet. And that's all divided by radius squared. Now if we look at this, these two planets here, this is my orbiting planet, right? So if I have here's a planet and I have another satellite or planet orbiting, when we're looking at centripetal force, we're looking at the part orbiting, okay? So this mass and this mass are technically my orbiting masses. So I'll put that there. These are all orbiting masses. So all my highlighted yellow is my orbiting masses. Now, looking at that, I know that these two here can cancel off. I divide both sides by m squared, they cancel off. So I end up with v squared divided by r is equal to my gravitational constant multiplied by my mass divided by my radius squared. Actually, I said m squared, we just divide by m too. So this mass here is my big planet or star. And this is the only mass I have left, because my centripetal force is referring to my orbiting one, and one of my masses here has to refer to my orbiting one. So theoretically, I do not need to know the mass of my orbiting planet. So if I want to isolate this for speed to know what speed it's going, we just end up rearranging this formula, so I get velocity is equal to my gravitational constant multiplied by my mass, and multiplying both sides by r, which cancels these off, all over my radius. And that's squared. So altogether, I end up with velocity is equal to my gravitational constant times my mass of my major planet, or my big planet, all divided by radius, and we have to square root it. Okay, so now let's get to my first question. My first question here is at what speed does the moon orbit Earth? Earth's moon is in orbit around 3.844 times 10 to the 5 kilometers from Earth. Well, let's figure this out. So once again, we're going to set it up how we should always set it up. We're going to say my centripetal force is equal to my gravitational force. Okay? So once again, we have my centripetal force is mass times velocity squared divided by my radius is equal to my gravitational constant multiplied by my mass of my big planet, in this case Earth, multiplied by the mass of my moon, all divided by the radius between them squared. Now, we look at this here. These masses are on both sides, so we end up with velocity squared divided by r is equal to my gravitational constant times my mass of the Earth divided by radius squared. Now I can multiply both sides by r, so I end up with velocity squared is equal to my gravitational constant multiplied by the mass of Earth divided by my radius. And then we must square root it to get rid of that. Okay, so let's plug this in here and see what we end up getting. We end up with 6.67, square rooting, 6.67 times 10 to the negative 11, all multiplied by 5.98 times 10 to the 24, and then we're going to divide this by 3.84 times 10 to the 8 meters. Because remember, everything must be put in kilometers. So this here we have to switch to meters. So I must multiply this number by 1,000. That's adding 3 zeros. So we just have that there. Now when I calculate this out here, I'm going to end up getting the moon orbits at a velocity of, which gives me a velocity of 1,119 meters per second. And if we look at this here, I have 1, 2, 3, 4. So 1, 2, 3, 4. We're at the right significant figures. Okay? Now let's take a look at my next question. So my next question here. I have a planet has a moon with an orbital period of 30 days. The radius of the planet is 2.2 times 10 to the 6 meters. The moon is 200 kilometers from the surface of the planet. What is the mass of the planet? So here I want to find the mass of the planet, which makes things a little bit more tricky, but it's not that bad. So we're first going to start off, same thing as always. We know my centripetal force is equal to my force of gravity. Okay? Now we have here my mass of my satellite, or the moon, multiplied by my velocity squared divided by my radius is equal to my gravitational constant times my mass of the planet multiplied by mass of the moon divided by the radius between them squared. Now, I look at this here, we are trying to solve for my mass of the planet there. Okay, so I'm going to have to somehow isolate for mass of the planet. So let's start isolating for this mass. First thing I'm going to do is, these divide each other. These divide each other. Now I have velocity squared is equal to my gravitational constant times my mass of the planet divided by radius squared. Now I'm going to, or divided by radius to the power of 1. Now I'm going to multiply both of these by my radius squared, multiplied by my radius squared. So then we're going to be left with, this cancels off, my velocity squared times radius is equal to my gravitational constant times my mass of my planet. Right there. Now, I want to divide both of these by my mass of my planet. By my gravitational constant. Okay? So, divide by gravitational constant. These are going to cancel out. So now, I am left with my velocity squared multiplied by the radius divided by my gravitational constant is equal to my mass of my planet. Alright, now, looking at this here, we don't know my velocity. But I know right here what is going to be my radius. My radius is going to be the radius of the planet plus the distance away from the planet. So here's my planet. We have this radius, and then we have to add the distance of the orbit. Okay? So altogether, my radius is going to be equal to 2.2 times 10 to the 6 meters plus 2 times 10 to the 5 meters. I have to change this into meters. Now we end up getting 2.4 times 10 to the 6 meters is equal to my radius. Okay? We also have to now look at what else do I know, my period. So my distance around here is I'm going to have to take the circumference of this and figure out how long it takes to go with the circumference. We know that's 30 days. So in this case, my period is equal to 30 days, and we want to get that to seconds. So that's going to be times by 24, because there's 24 hours in a day, times by 60 to get minutes, and then I times by 60 again to get seconds, which is going to give me a total of 2,592 seconds. Okay? Now that we have those, I know my velocity is equal to my circumference, which is 2 pi r divided by my period, or the time it takes to go around the circumference. Now we could plug all of this into my velocity there. So let's go ahead. So I'm going to get 2 pi r squared times r divided by my gravitational constant is equal to the mass of the planet. Well, that gives me 4 pi r cubed, because we have r squared, pi squared, 1, 2, 3 r's, all divided by my gravitational constant is equal to my mass of the planet. Now looking at this, I missed something here. Sorry, I made a mistake. I forgot to divide by my t, by my period. I didn't substitute all of this in for v, so we divided by my period, and then we divide by my gravitational constant. So then this here, we're also going to have my period squared, because the squaring has to be with the period as well. Okay? So, now we have all of this is equal to my mass of the planet. We know all my variables. We know my period and we know my radius. There's period, radius. These two here are constants, and we have a 4. So let's try this out now. I'm going to end up going 4 multiplied by pi squared multiplied by my radius, which is 2.4 times 10 to the 6 meters, and this is cubed, all divided by my gravitational constant multiplied by 2.6 times 10 to the 6 seconds, and that's squared. I just put this, we have 1, 2, 3, 4, 5, 6, and I rounded up to two significant figures. Now this is going to end up giving me a total of 5.457 times 10 to the 20 all over 448.12, which gives me a total altogether of 1.2 times 10 to the 18 kilograms. So this one here was a bit trickier of a question because there's a lot more to do and there's quite a bit of math to combine together to get